In this video, we will prove the midline theorem. So the midline theorem, a segment joining the midpoint of two sides of a triangle is parallel to the third side of the triangle, and its length is 1/2 of the length of the third side. So a midline of a triangle, here BD, is parallel to AE, and BD is half the length of AE. Here's the proof, and we will put it on the diagram. Make sure you understand every point because it's very long and pretty complicated. So first, B and D are midpoints given. Next, extend BD to F so that BD is congruent to DF. 2 points determine a line. So we will extend BD to F so that BD is congruent to DF. On this figure, everything has been done to scale. So remember on this is to scale. Next, CD is congruent to DE, definition of midpoint. So CD is congruent to DE. Then angle BDC is congruent to angle FDE. Vertical angles are congruent. So angle BDC right here is congruent to angle FDE over on this side. Vertical angles. Then triangle BDC is congruent to triangle FDE, SAS, side angle side. Side angle side, side angle side. So now we will switch to green, and then angle CBD is congruent to angle DFE, CPCTC. Corresponding parts of congruent triangles are congruent. So angle CBD over here is congruent to angle DFE over here. Now CB is parallel to FE. Reason, if opposite interior angles are congruent, lines are parallel. So to assist in the visualization of this, let's extend CA and let's extend FE. And then we have transversal BF right here. In opposite interior angles, make a Z. So you can see the Z in here. So then these are the parallel lines out here and out here. Therefore, CB is parallel to FE. If you're having trouble visualizing that, and a lot of people do, take a second, pause the video, work it out. Then BA is parallel to FE. BA is collinear with CB. So BA is collinear with CB. So if CB is parallel to FE, then BA is also parallel to FE. If you need, think transitive property. If FE is parallel to CB and CB is parallel to BA, then BA is parallel to FE. Next, CB is congruent to FE. CPCTC, corresponding parts of congruent triangles are congruent. So CB is congruent to FE right there. Then CB is congruent to BA, definition of midpoint. So CB is congruent to BA. If B is the midpoint of CA, then CB and BA are congruent to each other. Then FE is congruent to BA, transitive property. So if FE is congruent to CB and CB is congruent to BA, then FE is congruent to BA. It's much harder to see on a complicated diagram like this. It's the same as if A equals B and B equals C, then A equals C. Again, take a second, pause the video, convince yourself on that. And now we will go to here. ABFE is a parallelogram because a set of opposite sides are parallel and congruent. BA is parallel to FE, and also BA is congruent to FE. As you most likely know by now, if a quadrilateral has a pair of opposite sides that are both congruent and parallel, that quadrilateral is a parallelogram. So now we will start marking in red, again, just to keep everything straight. BD is parallel to AE because opposite sides of a parallelogram are parallel. So BD right here is parallel to AE. Next, BF is congruent to AE because opposite sides of a parallelogram are congruent. So the way we'll do this is I'll show that in red here and in red there. Those two segments are congruent because they are opposite sides of a parallelogram. Then BD is half of AE. BD is half of BF, which is congruent to AE. So BF is congruent to AE. And remember, at the beginning, we extended BD out to F so that BD is congruent to DF. So BD is half of BF, and BF is congruent to AE. Therefore, BD is half of AE. Again, pause the video, run through that, draw this out. You will not get it just by seeing it one time. draw it out several times. It's going to take some doing. If you're currently in a geometry class and you've been going through proofs on this channel with it, this is most likely by far the hardest proof you've done. You're going to have to actively draw it out and go through it. Notice we did the first part in orange, then in green, then in red. It's very hard to keep track of. You're going to have to do it about 4 or 5 times to get it. But if you can conquer this one, you are well on your way to getting a high grade in geometry.